A debris flow is a rapid mass movement of granular solids, water, and air as a single-phase system. Source area conditions for initiation of most debris flows include steep slopes, an abundant supply of unconsolidated superficial material, a large source of moisture, and sparse vegetation. Active landslide deposits, such as these in the headwaters of Heath Creek at Wrightwood, California, can mobilize into debris flows. Throughout the world, debris flows claim hundreds of lives and millions of dollars in property losses every year. The most common moisture sources are snowmelt, rainfall, and to a lesser extent, rapid drainage of glacial and volcanic crater lakes. These small hill slope landslides quickly form small debris flows and move into the main streams. Large masses of hill slope material may fall to the bottom of slopes, dilate or liquefy, and begin to flow. Debris flow fronts have a wide variety of morphological characteristics. Rocks and water are pushed and shoved along channels by the force of the debris behind the front. Debris flows proceed downslope in discrete slugs or surges, rather than as a steady, continuous flow. Surge periods range from a few seconds to several hours. Debris flow surges typically have three phases that change with time. Leading the flow comes a blunt, rocky snout, higher than trailing portions, and usually containing the largest concentration of big rocks. Behind the bouldery snout, the flow takes on the appearance of a more fluid, unsorted mud and rock mixture. This mixture, in turn, grades into a third phase, which is turbulent, muddy water. Here are some typical low, bouldery snouts. Here are some Japanese examples of higher, steeper, and faster debris flow fronts. In China, many debris flows originate in loess source areas and surge down valleys on a large scale. These debris flows lack the large boulders in the leading fronts. This debris flow at Wrightwood, California shows the three flow phases very well. In Rudd Canyon, Utah, this bouldery front quickly passes to the more fluid, unsorted mud and rock phase. Velocities of debris flows vary widely. Slow, creeping fronts move at less than 1 meter per second. Other debris flows move between 1 and 10 meters per second, depending on the character of the debris and channel geometry, including shape, slope, width, and sinuosity. The fastest debris flows exceed velocities of 20 meters per second. Freshly deposited debris flow sediments can be remobilized by subsequent surges from upstream. Some debris flows have relatively low viscosities. The flows can resemble wet concrete or dirty motor oil. Viscosities of debris flows can be 100,000 times greater than clear water. Debris flows can move in a completely laminar fashion. They can display some minor turbulence, or they can be highly turbulent. In this channelized debris flow in Japan, note the hydraulic jump at the bottom of the picture. In the next scene, several minutes later, the jump has migrated upstream. Note the difference in the water surface elevation upstream and downstream of the hydraulic jump. Shallow, swift debris flows can also develop stationary waves in open channels. New debris flow surges can appear as translatory waves passing through deposited material. Debris flows can transport very coarse material by simply pushing and shoving rocks within the flow with almost no overturning. Some rocks appear to float or bob on the flow surface. These exceptionally large rocks are being moved by overturning. Some exceptionally large boulders have been transported in debris flows. Note the arrow in the lower right pointing to a person for scale. The characteristics of debris flows have been directly measured in only a relatively few locations. This apparatus measures the impact force of debris flows. Direct sampling of debris flows can be a perilous task. More information is needed about the conditions under which debris flows occur. When and where will they originate? How far will they travel? And where will their vast amounts of sediment be deposited? These and many other important questions remain to be answered.